Okay, in this lesson, the learning target is I can find the average rate of change of a nonlinear function over a specified interval. So what all of that means is basically if you don't have a linear function, right, linear functions are the only functions that have a constant rate of change. That means you can add and subtract the same thing every time to get to the next value. Nonlinear functions, that's not always true for, right? So we can still find like an average rate where it's changing by, but we can't find a specific constant rate of change for nonlinear functions. So we're going to learn about how to find that average rate of change and what it means. So before we get there, though, let's find the rate of change of these linear functions. So both of these represent lines. And if you remember, the rate of change or the slope is calculated by the change in y over the change in x. So we're going to kind of look at each of your tables, decide what your change in y is, decide what your change in x is, and then you'll divide both of those numbers there. So take a minute and kind of complete this. Make sure you kind of refresh your memory on how to find slope or rate of change of a linear function. Okay, so once you've done that, let's talk about average rate of change. So nonlinear functions don't have constant rates of change. However, we can find the average change over a specified interval. So in order to do this, they need to give you 2 points that they want you to find the average change in. So that's what this point is talking about. If they give you an interval where the first number is a and the other number is b, the way you would find this is you do f of b minus f of a over b minus a. So we'll talk about what that means. So let's look at an example. So let's look at this relationship. I'm not sure what type of function this is. I always start by trying to calculate, see if it's linear. So I know if I add 2 here, I get 3, but if I add 6 here, I get 9. So it's not a linear function, but I can do times 3 times 3. So this actually grows by a factor of 3. So I can multiply. So this is exponential, right? And I can write, we've talked about how to write an equation for exponential functions. It's the y-intercept, which is 1, times the factor to the x power. So that's technically the function we have. It's not linear. But I want to find the average rate of change on the interval from 1 to 3. So this always refers to x values. So you want to find your rate of change when x is 1, between x is 1 and x is 3. So this is how we do it. We look at, sorry, not that point. We look at when x is 1, which is right here, and we can look at when x is 3, which is right here. Up here is if my interval is a to b 1 to 3, that means I need to find f of 3, that's my b value, so a, b, f of 3 minus f of a over 3 minus, oops, this should be 1, because my a is 1, 3 minus 1. So that's all it means. It's just plugging in those numbers for the correct letters. And if this is technically the change, so these are the outputs. It wants me to find the outputs at these inputs, right? So my output at 1 is 3. So I'm technically doing, I'm sorry, I'm not talking correctly. I'm technically doing f of 3. So I'm looking where my input is 3 and I'm looking at my output. So f of 3 is 27. And then f of 1 is 3 over 3 minus 1 is 2. So I'm just going to do 27 minus 3, which is 24, over 2, which is 12. So the average rate of change of this function is 12. And that's all you're really doing. And if you look, these both are y values, and these are both x values. So you're technically doing the change in y over the change in x, just for specific points and not for every point. You're kind of finding the average between those points. All right, so let's look at one more example just to make sure we solidify your understanding of this. And then there's just only a couple. There's 4 practice problems on this page. So let's look at a couple more examples. So it says find the average rate of change for the following functions over the interval from 0 to 3. Okay. So again, our formula for average rate of change is just f of b minus f of a over b minus a, which is over the interval from a to b. Okay. this is essentially just your change in y over change in x. So the way I like to do this, especially if I'm just given an equation, is I'm going to use my graphing calculator to my advantage. So it wants me to go over from 0 to 3. So I would just make a table where I have x values of 0 and 3. I know this is an interval and not a point because it has the square brackets there. So I'm going to type in this equation into my y equals. So 3x minus 1. And I go where x is 0 is -1. And where x is 3, it's 8. So now I'm just finding the change in y over change in x. Plus 9, plus 3, 9 over 3 equals 3. And that makes sense because this is a line, and the slope on my line is 3. So I should get 3 there. All right, B, I'm going to do the same thing. I'm going to put 0 and 3 in my table because that's the interval I'm looking over. And then in my graphing calculator, I'll just type in y equals 2 to the x power. And then I'll go to my table, and I'll just, it says 0, 1, and then 3, 8 again. So this would be plus 7, and this would be plus 3. So the rate of change here would be 7 over 3, which you can leave as 7/3. I don't like decimals. It would be a repeating decimal, so it's fine. And then my function c, notice this is a parabola because of the x squared. So it's not a line. It doesn't have a consistent rate of change. So I'm just going to, again, look at those 2 specific points. I'll plug it in my graphing calculator. I'll look at my table. At 0, I have an output of -4. And at 3, I have an output of 5. So I'm increasing by 9. I'm increasing by 3. My rate of change is 9 over 3, which is just 3. Okay, so this is really just finding the slope over an interval if it's not linear. If it is linear, your slope is your average rate of change. So your job is just to finish the practice, 1, 2, 3, and 4. Make sure you got the concept.